Welcome to today. So we've been talking about the master schedule, and you've at least been reading about forecasting. We're going to wind up those sections by finish talking about master scheduling today, by including safety stock, and then we're going to end with more of a discussion on forecasting, and then I'm going to discuss a vocabulary quiz we have coming up that you'll take sometime between March 10th and 13th. Usually what that represents is I'd want to give the class, I'd want to give an exam in person here. But I have an online section too, and so I want to make sure your people in here are not at a disadvantage at people online because they may cheat. So I'm having the same kind of assignments for everybody, the kind of assignments that's always open notes and everything that puts everybody on an even playing field. Remember, you've got a lot of assignments coming up. Very few of you have submitted any of them. And most of them are due, one's due the 15th, some's due the 22nd. You want to get those in beforehand, but of course I can't make you, there's a due date, but that due date is final. All right, everybody got a handout, correct? Okay, first we're going to be talking about this master production schedule where we're including safety stock. So safety stock is exactly what it sounds like. It's a stock you keep there just in case. It's kind of like, you know how you always keep your fridge on the inside of your house full of beer just in case. And you also keep the fridge in the garage full of beer just in case a friend drops by. And that's the normal stock, but in addition to that, you always keep a couple cases in the garage by the outdoor fridge just in case the stuff in the fridge starts running out. Because Norwood 3:16, a real man never runs out of beer, and a real Okie never runs out of beer. That beer that you have in the garage that isn't cold but can be put in the fridge in case the other starts running out, that's your safety stock. And as you can imagine, when you're producing things, no matter how good your forecasting team is, your forecasts are usually wrong, and so you want to keep some extra stock just in case. And what we're going to do, and that's what the safety stock is, and we're going to look at a real simple way of adding safety stock into our master schedule, and a very simple way of also making production decisions. Now, later in the semester, we're going to really be talking about how to make production decisions, like how much to produce each month. But then we're going to do it really sophisticated using like linear programming and things like that. But today we're just going to look at a real simple one. And so you've got a worksheet there, and what we're going to be doing that here. And so this is the same kind of outline that we've had so far, where we know what the forecasts are, we know what customer orders are already, and we know that beginning on hand I have to give you the first number. And the rest of the number are like formulas. They're based on what safety stock and production is. And what we're going to do is we're going to say, let's suppose we come up with a very simple rule for determining safety stock, where first we say the amount we produce each month is always going to be equal to the forecast plus the orders plus our safety stock. And so for March, we see that people have already ordered 81 units, and we expect 119 more than that. So we know we want to produce at least that much, but then we want to add some more safety stock in there just in case people order more than we think. And our rule for doing this is as follows. And you might imagine this is a simple rule you start with to see what the numbers look like, and then you go in there and change things by hand from there. But what we do, we say, if beginning on hand inventory this month is less than 20% of forecast plus orders for next month, then we're going to set our safety stock to 15% of next month's forecast plus orders. Otherwise, we're going to set safety stock equal to 0, and if safety stock is a fraction, we're just going to round up. So what we're going to do here is we're going to use our order. We're going to use our little rules of thumb. And we say, okay, if beginning on hand inventory, which this month is 20, is less than 20% of forecast plus orders next month, Okay, so let's look at what that is. Right now we're in March. In April, forecast plus orders is 300 plus 0, and then we go 20% times 300, and that gives us 60. Is 20 less than 60? Yeah, very good, Courtney. 20 is less than 60. So that means for next month we're going to set our safety stock equal to 15% of next month's forecast plus orders. So then I go 0.15, 15% of next month's forecast plus orders was 300. And that looks to be 45. And so that means we know our safety stock here wants to be, we want it to be 45 according to that rule. And then we said that the amount we're going to produce is going to equal the forecast plus the orders plus our safety stock. And so we're going to produce 245 units. Now the projected available balance is calculated exactly the same. You don't include safety stock, but we say we expect at the end of the month where we know we produce, we start off with 20 units, and then we're going to produce 245 units. We've already sold 81 units. We expect to sell 119 more units. And so we project that at the end of that month we'll have 65 units left. Which means for beginning on hand for April, we think that's going to be 65. And then what we have to do is then say, okay, well, what are we going to do for April safety stock? Well, we're going to use the same rule. And so we would look and we say, okay, beginning on hand is 60. Is it less than 20% of next month's forecast plus orders? Well, forecast plus orders next month's 350 plus 0, so 350 times 20% is 70. And beginning on hand is 65. And is 65 less than 70? There you go.
What happens if you're under?
What's that?
What happens if you're under?
Under what?
Like if your beginning on hand inventory doesn't meet the safety stock threshold of 20%. Is that right?
If beginning on hand is less than 20% of the two. And you're saying what?
I guess what happens then if it's, yeah.
It's 0.
What happens if it goes over that threshold?
Yeah.
You just no safety stock.
Okay.
It's like a way of saying once you reach that threshold, we don't need any more safety. We've already got a big pile there.
Sounds good.
It's kind of like saying how big of a pile are we comfortable with? And so for our safety stock there, we go by the rule and we know it's going to be 15% of forecast plus orders next month, with this 350 plus 0. And that is 52.5. We'll just round up to 53. And like before, the total amount we produce is going by the rule. The forecast above orders, plus the orders that already exist, plus our safety stock of 53, 353. And then we project how much we think we'll be left with at the end of that period, where we know we started with 65 units, and we know we produced 353 units. There are no orders, and then we forecast we're going to sell 300 units. So we project at the end of April we'll have 118 units, which means at the beginning of May we'll have 118 units. And then we've got to do our rule again. Our rule says that we produce safety stock whenever forecast, 20% of forecast plus next orders is above beginning on hand inventory. So we say 20% times 800 is 160. So 20% of 800 is 160. So do we need to produce some safety stock? You know, yes. Okay, and then safety stock is just going to be 15% of 800, which is 120. So our safety stock, 120. Now the amount we produce equals the sum of our safety stock plus orders plus forecast. A lot, 470 units. And then we project at the end of that period. We start off with 118. We're producing 470. We think we're going to sell 350 units. So we project that we're going to end that period with 238 units, which means we begin the next period with 238 units. And then again we say, okay, do we need safety stock? Well, 20% of however much we know we're going to need next period of 300, 20% of 300 is 60. Our beginning on hand is way bigger than that. So here we don't need any safety stock. Those rules tell us that for what we see in the future, this pile of inventory that we have of 238 units is more than enough to be safe. We're comfortable with it, so we don't produce any safety stock, which means the amount we produce just equals the amount that we plan to sell, 800. And so we expect to end next period with just 238 units, which means we're going to begin next period with 238 units. And then we just stop there because we don't have a forecast for what August is yet. Right now it's really only March. And so we just stop there. Which is why I have that a different color for the safety stock in July. So this is just a simple rule we use to plan. It's like beginning of March now, so this is our plan for the next 5 months. And as we go and as time unfolds and we go to our SROP meetings and we look how forecasts change, we can come here and change some of these things. But that's just a simple rule we can use to start with to say what we plan to do for the future. You know, this was just based on a really simple rule. It didn't take into account inventory cost or anything like that, so it was really rudimentary. And so that's why later in the semester when we get into programming, we'll use more sophisticated things for that. And what I have on the rest of these slides is just instructions for if you were going to use these if statements. If you want to, instead of just saying to yourself if and doing the calculations by hand, if you wanted to plug these in Excel, these are like the if statements you would use. And let's see if those numbers we did are correct. Well, something's different. I messed up somewhere. $65.18, $238. No, I guess not. No, looks the same. Okay. Does that make sense? Okay. As you can imagine, there's tons of different ways you can make decisions about safety stock, but you always have safety stock. Know that sometimes, like if you're setting a contract with the input supplier, like if you're the gum company and someone provides you with chicle, sometimes companies will write the contracts saying that you provided me with chicle will always keep a certain amount of safety stock reserved just for me, so just in case something happens, I have that safety there. So safety stock can be stock you kind of keep for what your customers need later. This, and we did safety stock here in terms of things we're producing to sell to other people, but safety stock can also be in inventory, and that's what we're going to be starting on Thursday. So like if you're buying chicle, you keep chicle inventories for your gum production, you may want a safety stock of chicle as well. And by the way, next Thursday is when this class takes a really big turn. So far, this class has just been verbal descriptions of supply chain management, mainly vocabulary, some concepts. Starting on Thursday, we're going to be talking about inventory management, and it's all going to be done through calculus. And so things get very different there. And then after that, it becomes programming, where you don't do calculus yourself. You set up a computer to do all the big number crunching for you. Okay. What I'm doing here is I'm winding up our content on forecasting. These slides are also in your thing. You should have all the slides there. And I'm introducing more vocabulary you're going to be responsible for. So with forecasting, you've done a couple things. One, you've read some pages from a chapter from a textbook and you're taking a quiz on it. Two, you're doing a forecasting assignment. What I want to do here is talk a little more general about how forecasting is actually used in companies. And so we have these four different methods here. This market research, where that's when if you have a very new product for which there's no data that currently exists out there. You know, it's nice if you're selling something and you want to know how much are we going to sell in the future. It's nice if you have data on sales in the past, but if it's a brand new product, you don't have that. And to figure out just how much people are going to like it, how much they're going to value it, sometimes before you go on the market, you just want to do consumer research. So maybe you do focus groups. And by the way, I teach a class in the fall called Researching Consumer Food Preferences that's all about how to do focus groups and consumer surveys. But you do focus groups where maybe you get people to taste this new flavor of gum you have to see how much they like it. You can do surveys where you ask people about how much gum they tend to chew, and like if you have a new cilantro gum coming out, how likely they are to buy that cilantro gum. And sometimes you can do actual real taste tests. These methods are useful but imperfect, and sometimes it's better. You know, we learned that in focus groups and surveys, people lie in general. People lie all the time. They lie to themselves. If you ask people, like if you have a new type of food out there, how likely they are to buy it, they almost always overestimate how much they're going to buy it, partially because they're trying to make you happy, things like that. And so sometimes you just have to use personal judgment. So whether it's people on your sales force or just people who's worked in the industry a long time, these are people who can come in and say, okay, I know these people told you they really, really want this cilantro gum, but they say that about everything, and they're not going to buy it as much as you want. And so maybe we need to adjust those things accordingly. A lot of businesses have kind of learned that the market research really isn't all that useful, and it's best just to make guesses based on people who've been in the industry a while. And these time series methods, that's what you're doing in your forecasting assignment, where you're taking this hypothetical sales of a certain good and you're deconstructing it to say what has the general trend been over the years, what seasonality been like over the years. Based on those past trends, then what do we think sales of this new gum will be? So time series is just when you look at past trends without really asking why those trends occur. But then you have a thing called econometrics. I don't know if you've ever heard of that word, but if you've ever done a regression, that's usually econometrics. And that's like if we said, well, what we found is that people buy more chewing gum when the weather gets warmer, then maybe we can predict sales based on the temperature. So that's when we take an indicator variable, something correlated with sales, something other than past sales, and use it to predict the future. All four of these are used all the time. I'm thinking most of the time the two most popular are judgmental and time series. And they're also far less expensive. And of course, you don't have to, it's not on here, so you don't have to know this. One of the best things to do, if you could have a test market somehow, because that's the real test. And so if you can find a couple grocery stores that will put your cilantro gum on sale for a little while and see what that test market does, that's often the best thing to do. But that can be hard because most retailers don't like being a test market. They only want to put things on sale that they know people want to buy. But sometimes they're willing to experiment. Okay, so let me give you, and this is straight from the textbook where I give an example of how companies may actually put together a forecast using different methods. And so let's say we're coming out with this new cilantro flavored gum. And we want to say, we want to know just, are people going to buy this thing? How many people are going to like this? Who likes the idea of cilantro flavored gum? See, I think it's a great idea, but y'all don't. So far, this isn't looking pretty good. But I have more money than you, so I can move the market. Well, not Mr. Montgomery, I didn't mean that. I do not have more money than you. I'm so sorry. And so what we do, maybe we go out, we hold taste tests and focus groups, and we find that, hey, could someone shut the doors over there? I don't mean to bother people. The doors to the library, one there. Thank you, Rachel. Suppose we actually do taste tests with people, and we find that maybe 10% of people say, yeah, I actually really like this gum. And that's good news to start with, because you got this weird gum coming out that nobody in the company thinks will work, and your surveys and focus groups say, yeah, 10% of people are actually crazy enough to eat cilantro gum. There's a cilantro ice cream, by the way. But people who don't like it strongly prefer other flavors. So you've got this starting point where it seems like of all the people you studied, 10% really like this gum. And of course, in the study, you have to define what really like means and everything. And there's a lot of semantics there, and there's a lot of judgment there. So even if we have this number, 10%, that came from a judgment of what really like means. Like maybe on a questionnaire, they had to, on 1 to 10, how much do you like it? Really like means 7 or above. And then the rest certainly liked other flavors. And we want to know, what we got to do is we say, well, we're going to sell this gum. How much do we think we could sell if we let consumers buy as much as they wanted? Well, the first thing, what you like to do in these situations is that's a really hard problem, right? You don't have near enough information to answer this thing. And so what you do is you take the really complicated problem and you break it down into a series of really simple problems. And this is one way of doing that. So we start with one simple problem. We say, how many total packs of natural chewing gum does the company sell this year? We know that. And we have someone look up the records, and they find that we sell 1.5 million packs per year. So we're starting with that. 1.5 million packs years are sold, and we say, well, our market research suggests 10% of people really like the cilantro gum. So maybe that suggests we'll sell 10% times 1.5 million, 150,000 packs of this cilantro gum. Now once you do that, you then have to say, okay, we got this new gum out there, we need to decrease our forecast of other products too. If people buy more cilantro gum, they're buying less of our other gum. So we know we need to do that, but that's not the problem we're really looking at right now. And so let's get back to cilantro gum. But then what we say is we get people together and we say, okay, we know this 10% number is a bit BS. It's not going to be 10% of people buying gum are going to buy our cilantro gum. It's way too high. Well, how high is it? Well, we don't know. But based on our experience with offering other new products, we think 3% is a good number. We actually think, based on our research, that 3% of people who buy our chewing gum will actually prefer the cilantro gum. And so what we then do is we say, now let's take that 3%, multiply it by the 1.5 million that we sell of all gum every year, and we estimate we'll get 45,000 packs of gum each year. So we took a problem that can't be answered, but we just broke it up into simple problems. That's how most of this stuff's really done. And yes, we used data. We had hard data on how many total packs of everything was sold. And we have good data from our market research, but we also know that the market research is flawed somewhat, and we have to use expert judgment to tease it apart and figure out what a good number is. And then so we come up with this forecast, 45,000 packs per year, but then if you're making this presentation to your boss, you immediately protect yourself for when you're wrong, because you're going to be wrong, by then saying, here are reasons why this could be an underestimate, here's why it could be an overestimate. It's just our best estimate. And if your boss has any experience in this industry, then she knows that it's just a good guess, and they will be wrong to some extent. And so that's how forecasting is really done. I once interviewed, so you know Stillwater Mill, they have the Agri Center over there, and I once interviewed them about how they do their forecasts. So one thing they sell is feed for cattle, like winter feed. They sell these like alfalfa pellets and stuff. And for them to figure out how much pellets they're going to need to buy for the winter to sell to their customers, they get a group of people together and they routinely discuss things like, what's the cattle price? What do we think we're going to be selling these pellets for? What have been the trends in cattle production in this area over time? What are things, they watch the extension people like Dr. Peel talk about the market outlook for cattle. They get as much, and of course they look at past sales as too. Look at trends from past sales, seasonality, and they just come to a best decision on what the forecast will be, and there will be, you know, maybe 4 of the main people at Stillwater Mill. A couple people who work at some of the other branches will teleconference in, and they have to forecast everything from the amount of this cattle feed they're going to sell to how much radish seed they're going to sell in their individual stores. So while this class is mostly about crunching numbers and stuff, there's of course a lot of judgment being used as well. And nothing substitutes for industry experience. One thing I really want you to know is the term stock keeping unit, because you know, if you took a job today at a business and if they do a lot of supply chain stuff, they'll probably just start saying SQUs or SKUs without even thinking about it. They use the term so much that they would never even think that someone else doesn't know what that means. And so what does it mean? And this is the actual definitions from the Association for Supply Chain Management, and they use examples which I think work. So they say one, so it's always some kind of inventory item, but one way of thinking about it is like anything that has a barcode with a unique number is usually going to be an SKU. So if you have a shirt in 6 colors and 5 sizes, that's going to represent 30 different SKUs. So one SKU for each shirt of a unique size and color combination. Because you need to have these things in inventory, so when they're sold and the barcode is scanned, you need, in your inventory, you need to subtract one so that when the inventory of a extra large AGEC Center orange t-shirt goes down by 1 or gets low enough, you need to have the computer tell you that you need to order more. And then, so as you could imagine in the AGEC Center, anything that is a unique item, for instance, they'll have different types of radish seeds for sale, but they're, and a lot of different radish seeds, but different varieties of radish seeds. So every different variety of radish seeds in a different size packet of seeds is going to have its own SKU because they need to be kept track of separately, and they sell at different prices. But also, you know, with supply chain management, you have this flow over many different units, and maybe you have items in a warehouse 20 miles away, and you have items in your store here. And then you have your chicle supplies, which are often this other warehouse over there. And so let's say we have, imagine with our natural chewing gum, we have chicle inventory at our warehouse 20 miles away, and we have chicle inventory here. Then we may want different SKUs for the same chicle in different places, because we need to know how much do we have here and how much do we have there. And that's why they also say in a distribution system, an item at a particular geographic location. For example, one product stocked at the plant and at 6 different distribution centers would represent 7 SKUs. The reason people just say SKUs without why it's emerged as such a ubiquitous term is sometimes you have to be really precise. So if we're in an AGEC Center and we're talking about shirts and we say, well, how many shirts are in inventory? Well, those orange shirts, we have 180. But that's not what you need, because we need to know how many extra large are there for big boys like me and Brock, and how many smaller ones for smaller people like little Ethan over here. We need, the inventory needs to be kept separately, and so the word SKU came out as a way of specifying. Say, when I say how many of each SKU of these shirts do we have, it's a way of saying we need to be really specific about which items we're talking about. Another thing forecasting is used for, and analysis of sales, is something called consumer segmentation. It's a really simple concept. It simply says that, well, like, so Gianna wants to be a salesperson, and one thing she's going to learn is she has lots of different clients. Some clients are more important than others. And generally, the people who spend the most money with your business are the people who are most valuable to you. Because Gianna has to ration her time. She's only got so many hours a day, and she needs to make sure those very important clients are taken care of first. Ditto when we're talking about all these different varieties of chewing gums that we have. So here, this is a case where we have a bunch of, I can't remember how many was here. What's the biggest number there? Well, we've got a bunch of different varieties of chewing gum there, maybe 30. And we need to develop forecasts for each variety of chewing gum. How many do we expect to sell of cilantro flavor versus spearmint flavor versus cane sugar flavor? And, well, maybe, and some types of forecasts you put together are easy. Sometimes, if an item is very important, you want to put a lot of time into that forecast. Think back to AGEC Center. They're going to put a lot of effort into figuring out their forecast for total amount of cattle feed sold, because there's a lot of money being exchanged there. and very little time put into forecasting how much of their daikon radish seeds in 30 seed packets are going to be sold. It's just not worth spending a lot of time on. And so that's segmentation. We take all these different items we sell and we say, let's segment them into the most important, least important, and so on. That's what consumer segmentation is. And of course, there's a lot of different ways of doing this. The first one you learn when you learn supply chain management is this ABC segmentation. And that's when you do something like this. So we have, notice our gun type or SQ or SKU, and what we do is we calculate annual revenues per SKU. And the percent of total revenues each SKU is responsible for, and then we rank them accordingly. And so we have this NTCG gum, with maybe as natural tangerine chewing gum, and it's responsible for around 18% or 3.4% of total revenues, more than any other gum. So that gum is the most important gum we have. The next most important is NRCC. Maybe that's natural rosemary chewing gum. And even though it's, I guess we'll rank them just by annual revenues here. It has the second highest revenues. Oh, that percent of total SKU, that's something a little different. It's used to make this curve, so don't worry about that. So here, these gums, if you look at the total revenues, you could easily see why I chose to call these gums Class A versus those other gums. It just looks like a natural dividing line there. And so those 1, 2, 3, 4, 5, 6 gums that give us the highest revenues, I assign those to segment A, and those are the important few. This is just kind of lingo that's developed. We call A important few. Now, then we have a bunch of these other weird little chewing gums, like cilantro gums, that sell, but they don't sell that much. And you can see I give these C, so these have really very little revenues. Segment C is the trivial many. If one of those gums disappeared or our forecast for that gum was off, that's not a big deal. They didn't make us much money anyway. And you can see how I chose the dividing line between B and C. That just seems like a natural break there. And then anything that's not A or C, we call B. We call it the middle share. Now, what you need to know are those words and what they mean and what they're used for. Sometimes in this class I give you data and I have you decide which is A, which is B, which is C, but I don't think I'm going to do that this year. But the point of the thing is we identified the most important gums, the trivial many, and the ones that are kind of in between there. And then we say, now let's have a different forecasting method for each gum. And that's the purpose of this. So what we do here is maybe for segment A, maybe I've got 3 grad students in here, so maybe I'm going to put them, they're going to be my quant team. They're going to do a very, very detailed analysis on each of those gums, looking at past sales. They're going to do the same thing that you're doing on your forecasting assignment. So I'm putting a lot of resources into that. For the trivial many, maybe I just say, let's just make our forecast equal to sales from last year. It's just not worth putting a lot of time into. So how much we sold last year, let's say that's how much we're going to sell this year. So I put very, very few resources into that. And then for B, I kind of go somewhere in between where I say, okay, let's see if there was a trend in the past. And if there's so, maybe we'll take average sales from last year. But if there seemed to be some kind of trend in the segment B, maybe we'll bump up that average a little bit, maybe we'll bump it down, but we'll make little adjustments. And so all we did there is making sure we don't waste resources. We put resources to where it's most needed. Pretty simple, right? I'm going to have a couple things from some reading. So there's something called Supply Chain Drive and Food Drive. It's like an industry newsletter that people in supply chain management read all the time, and so I keep up with it as well. And here they had a lot of articles talking about how companies were adjusting their supply chain management strategy in reaction to COVID. And notice in the articles, you know, in their title, they just say SKU. And there's nowhere in this article they're going to tell you what SQU stands for. So that's how important it is to know words like that. Because they assume if you don't know what that is, you don't need to be reading their newsletter anyway. So that's what they did when Coca-Cola, when COVID came. And before COVID, they had this ruthlessly efficient and sophisticated supply chain for producing and then distributing all their different varieties of soda. But then when things got crazy, they said, okay, our supply chain management was not built for this. The computer programs that were helping us, they're not useful anymore. We've got to think as humans, and we got to think on our feet, so that means we've got to simplify things. And so they just simply drastically cut their number of SKUs they were doing. So this could mean a couple things. This could mean maybe Coke said, let's just don't sell cherry Coke anymore. But more likely what it was, they said, okay, we were selling pallet loads of Coke. You know what a pallet is. And a pallet is usually, you take that pallet and it's like, I don't know, maybe 4 or 6 feet high, but it's a standard unit. They said, okay, we were selling Coke by the pallet load. That was an SQU because it's one volume. And then we were selling partial pallet loads. That was another SQU. Now we're just selling by the pallet load. If you can't buy a whole pallet, you've got to go somewhere else. We don't have time to deal with partial pallets. I don't know if it's Coke, but there was, I think one of the cheese manufacturers definitely had to do this. Okay, and the ending is this. So I'm going to talk a little bit about artificial intelligence in forecasting, because it's something you're going to see a lot. Whenever a supply chain management company is trying to sell companies software to help them with their supply chain, they're always going to tell the companies that we use artificial intelligence to help you with your forecast. We use machine learning. Most of the time when they're saying things like that, it's more than a little bullshit. And I want you to understand, what these things are and why they're really not that useful for forecasting. So in general, when we talk about artificial intelligence, you can talk about it can be machine learning, which probably isn't what you think of when you think of artificial intelligence. And then you have deep learning, which really is artificial intelligence. So machine learning. Machine learning, when a company says it, it can mean anything. It can be simple correlations. It can be if statements in Excel. It can get sophisticated. A lot of the search algorithms and product recommendations are best described by machine learning. So when Amazon recommends something to you, they're using something machine learning, and it's kind of simple, but if you actually, I read about how it actually works one time, and it's really not simple at all. It's really not complex at all. Basically what they do is they say, okay, this person just bought this book on Amazon, and then they look in their records, and then they basically see when other people bought this book in the past, they've also bought this other book. And so it is machine learning that there's a lot of number crunching involved, and it's certainly more sophisticated. I'm making sound, but conceptually it really is that simple. And they have to make it simple because their database is so large that they can't have, if it got sophisticated, it would be too much. No, you have to have something simple to handle that much data. So the point is machine learning can be something really simple, things that an undergraduate can do. It can be more advanced. And this is from that book. I'm going to give you an example of one type of machine learning that they can do. So let's suppose we're selling these meal kits. where people, they buy this meal kit. It comes to them with all the ingredients and instructions on how to cook them. And of course, if you're a company doing that, you definitely want to make recommendations for people on what type of products they actually may like based on who they are and what they bought in the past. So one machine learning algorithm that you can use is something called decision trees, which conceptually is kind of simple. So let me show you like an end product. Suppose we're running this company and we have enough data where our customers have bought things from us. We know the demographics of that customer, like their location, their gender, their family size, and we also have their feedback on the items they bought. So we know if they got like a Salisbury steak dinner to cook, we've got their ratings for it, how much they liked it on a scale of 1 to 5. And you can put this all into a machine learning algorithm, and it can output things like that, where maybe we've got a particular customer, maybe Sam's a new customer, and we need to know, and maybe she's bought 1 or 2 things from us in the past, we need to know what to recommend for her. And this decision tree first says, is she located in the Midwest? And yes, she is. And then it says, is her income greater than $50,000? You make more than that? So, no, she doesn't. And so then it says, did they try and like the chicken parmesan? And suppose she did, and she gave it a rating on a scale of 1 to 5, it was above 3. So if she liked it, then we say yes, recommend the turkey and gravy dinner. Now, how did we get those rules? It was based on you using historical data where you find that people who do live in the Midwest, who also make less than $50,000, who also tried and liked the chicken parmesan, they also tried the turkey and gravy and they liked it. So you're just looking at, you make these decision trees, these rules about recommendation, and then you look and see how well those rules would help you predict things you've already sold. And you just refine the decision trees from there. And so this is useless if you don't have a lot of historical data. So you have to have a lot of people in the Midwest making under $50,000 a year who did try the chicken parmesan and gave us a rating on it. If you have enough of that data, then these things can work. But these things really do require a lot of data. You know, if you just want a decision tree with like 2 limbs, you don't need much data. But if you want something really specific, you do need a lot of data. And a lot of times for businesses, that data is just not going to be there on this detail of a level. Of course, they're trying to get there. That's why they want your information so bad. That's why they're letting you do this Robinhood app for free. Is it free? It's not free, right? It's completely free? You can actually buy a stock. Well, you can't buy a stock for free, right? Yeah, there's a fee there, gotcha. The app itself is free. Yeah. So machine learning can be sophisticated like this, but again, it can be as simple as, does Sam live in the Midwest? Yes, recommend turkey and gravy dinner. That's not very sophisticated, but if you're a company and you call it machine language, your customers are going to go, wow. In reality, your customers know you're bullshitting you, but when you're in this market, you got to use these. One way of saying that word is showing you know what machine learning is, that you are a progressive firm. So most of the time, even when they're bullshitting, the people know they're being bullshit on. Now, the next thing is deep learning. And this is real AI because it mimics the way our minds actually work. There's a thing called artificial neural network that's a predictive model whose structure is based on how our brains actually work. And you can think about it like this. So if we used our previous example, it's kind of like you get information on customers' regional location, their purchase history, their ratings of historical products. And then just think of this as a really horribly complex mathematical function that absolutely nobody can understand and computers can barely even compute it. But it's kind of like this. Your brain does this. Your brain is taking in all these sensations, millions of sensations right now. The temperature, the time of day, how hungry you are, whether someone just coughed, whether my voice is getting annoying at this time of day. Each sensation comes into these things called a node, and it sends an impulse, electrical impulse along to another neuron. And these other neurons are getting that sensation plus 1,000 other sensations, other impulses. And if the number of those impulses reaches a threshold the brain has to decide, it sends electrical impulses to these other nodes. And you're just this horrible complex mathematical function that takes inputs and makes it outputs. And it's so complicated that it can capture anything. It can capture any idiosyncrasticity. Now, this is what they're using, I think, partially for search algorithms, but definitely for facial recognition. For instance, when they are trying to do facial recognition, what they do is they feed the visual inputs as far as pixel information into the neural network. The neural network tries to decide whether it's whose face it is. And if they get the wrong face, feedback comes back, and the neural network is changed. They evaluate a new prediction, and if that new prediction is close, then it says, okay, we're on the right track. Let's make some more changes, but not too big. And so, and it's just kind of like, well, I don't really know. I know what Courtney's face looks like without a mask because she was my advisee. So I can recognize Courtney's face. I can pick her out of a lineup. I've had to do it before at a police station. But I don't know how I recognize. Like if you ask me how I recognize Courtney's face, I don't know. It's a thing. It's a face. I can try to describe features of her face, but that's not really how I recognize it. I'm trying to figure out how my own brain works, but I don't know how my own brain works like that. I just look at a picture and my brain tells me, there's Courtney. And it's the same way with these neural networks. You can't understand how it works. There's no way to look inside it. And for them to work, you know how if you ever estimate a regression or a trend line, you just estimate two numbers? Like on your forecasting assignment where you do a regression, you just estimate two numbers. And these things, there are more parameters you have to estimate than data you have. It's just that complicated. But that's why you have to have a complicated machine to be able to look at all these different faces and say that's Sarah and that's Courtney, because you've got to be able to take in so many different things and have so many unique outcomes. Okay. Now, all I'm trying, and so when Facebook wanted y'all to do that 10-year challenge, they're using that to get before and after pictures of you for their neural networks to predict how people are going to age over time. You know how when you're trying to get into a website and they make you pick out each frame with a stoplight in it? They're trying to figure out, okay, which frames actually have a stoplight, and then they give that information to neural networks to give neural networks to practice on, to see if the neural networks can find spotlights as easy as you can. So most of the time they're doing that. They're getting data from you to feed to neural networks. You're training these neural networks to try to be as smart as you. Okay. This has absolutely no place in forecasting, because you just need an enormous amount of data to make these things run. And no company sells that much data. Sells enough product to generate that much data. Now here's the main thing. This is the takeaway. So I do want you to know generally what machine learning is, that it can be simple or complex. I do want you to know that deep learning and artificial neural networks are really, really, really complex, and that's real artificial intelligence. But the main thing for forecasting is this. The really sophisticated AI tools only work in cases where you have they would only work for forecasting if you had an enormous amount of data and the structure of preferences did not change. And by the structure of preferences, I mean like, let's say, so when I was in college, we drank sodas all the time. On average, each person probably drank 2 a day. And now, I don't hardly ever come to a class where people are drinking soda. Y'all just don't do it. You know it's high sugar content is bad for you, it's bad for obesity. Y'all tend to drink water or Red Bull, something like that. But also, it's just not what people do, right? I mean, you just don't do that. The structure of those preferences have changed. So even if you did have sales data on soda from the 1990s, that's just not useful for predicting sales soda today. So not only do we not have a lot of data, in cases where we do have a lot of data, the structure of preferences changes so much that historical data isn't really all that useful. And so AI, for these reasons, not limited amount of data, the structure of preferences for consumer goods always change, AI is just not useful for it at all. You can still say when companies say they're using it, they're saying it to say, I know these words, but the actual algorithms they use are going to be much, much simpler. And people with industry experience, they know better than to put too much trust in it. Last thing, so this was Tillamook is a cheese company. Let's see, they supply, is it grocery stores or food services? I think they specialize in supplying grocery stores. Do they sell Tillamook in grocery stores? Anybody know? Let's say they do. Well, anyway, COVID came, and so all of a sudden, people in the food service establishments, hospitals, restaurants, weren't buying that much cheese. People were consuming more food from home, so they were buying more from grocery stores, so their cheese sales soared. And this is from the Supply Chain Drive article. They say, the planning team is hard coding forecasts because without the manual override, the machine learning software is basing forecasts on recent data and calling sales in the next 6 months at a much higher rate than before COVID. Okay, so they were actually probably selling to food establishments. So they say they've got this software, and it says it's using machine learning to forecast. The people using that software at Tillamook, they have no idea what kind of algorithm those machine learnings are doing. Probably all it's doing is just looking at past trends and extrapolating it. Really simple. And then what happened was, so they were selling a lot to hospitals, schools, things like that, but then COVID hit and that demand fell. Well, these algorithms are saying, well, you sold a lot in the past, so you're going to sell a lot tomorrow. That algorithm doesn't know that the pandemic hit. And so it's still throwing out these big forecasts. And so the people at Tillamook had to say, well, these forecasts just don't work anymore. So ignore them. We're just going to give our best guesses now on what demand is going to be based on what we're seeing. Okay, that's the end of the lecture. Let me show you about this vocabulary assignment real quick. I'm sorry, I meant to print copies and hand to you, but it's online. So at modules, there's a new module here called Big Assignments Coming Up, SCM Vocabulary Quiz 1. You can click on this, and it's going to give you this description. And what you see right here is basically what you're going to see when you actually open up the quiz. And it is a vocabulary quiz, and these are the words you use. So you need to know these words. You are going to, it's important to have that list in front of you because you are going to have to type it in exactly as the words are. So if we have the divided line, you can't put in divided line, you have to put in the divided line. Now don't let this worry you because you're going to have 15 times that you can take it. When you actually take it, now this is going to sound scary at first, but I've spent a lot of time with this. I really don't think it's that bad. It's a way for me to try to make sure you learn this vocabulary, but in a way to reward those who do, who didn't cheat. Okay. You're gonna, what it's going to do, you only have four minutes to take it, but there's 15 words. So I think there's like 31 total words. It's going to randomly present you with 15 of them. It's going to look like this. So we're just previewing it right here. And it's going to show these words again. It's going to show you one at a time. So this says, it's always going to start with the first part that you'll learn to ignore. You get down here, when a new order is placed for 10 units in March, the forecast for March is reduced by 10 units. So I know that's consuming the forecast. And it has to be entered exactly like that. Then I go next. It's going to present the other one. A format that includes time periods, blah, blah, blah. That's just master schedule. And you're going to do this for 15 questions. And then you submit, and it's going to show you whether you got them right or wrong. So I got these two right, these other ones wrong. And see, you only have 4 minutes to do it, and there are a lot of words there, but you can take this up to 15 times. And you can add, your score will be the highest score on any of them. Not the average, but the highest score you make on any of them. You can take the quiz anytime between February 10th and February 13th. And because each question is 30 points, the total assignment is 450 points. Please don't wait till the last day to do it because I'm not going to set them after. I'm giving you this much time to help you with your schedule and because I know Canvas can mess up. My wife teaches intro AGEC, and her students were supposed to be taking this quiz, and all of a sudden the quiz just disappeared from Canvas, from her, from everybody. And it could happen, so that's why I'm giving you so many days to do this. Okay, and that's all. I will see you Thursday. Sarah, did you ever hear from Lauren?
No, I wanted to talk to you about that, because I wanted to talk to you about the stuff for like research methodology and kind of other stuff.
Yeah.
I don't know.